In this video, we're going to talk about how to get the derivative of a general exponential function. So, whenever you're looking at an exponential function, it'll take the form a to the power of x. The derivative of it is going to be a to the power of x ln a. But perhaps a better way of looking at it is the derivative of a to the x is equal to a to the x ln a times the derivative of x times dx, or an even more all-encompassing way of looking at it is the derivative of a to whatever is in the exponent is a to the exponent times ln a times the derivative of the exponent. So to demonstrate that, let's do an example. So suppose we're given a function f at x is equal to 3 to the power of 2x, and we're asked to find the derivative of that. Well, the derivative f prime at x, we'll call it f prime at x, is going to be, we're just going to follow this format here. So a to the whatever the exponent is, so 3 to the 2x, 3 to the power of 2x, times ln a, in this case a is 3, ln 3 times the derivative of the exponent, okay, and in this case the exponent is 2, so we'll multiply that there, okay, so times 2x, which is times 2, okay. Okay, so now the next thing we have to consider is this. Okay, so we can simplify this even further by basically doing this. Okay, so we can also write it like this. We can take this 2x here. Okay, so remember that 3 to the power of 2 is 9, so we can write 9 to the power of x ln 3 times 2, right? And there you have it. So that would be the derivative of this function here. Now, another thing we can do another example here. So we can do a slightly more tricky example. So we can go, let's say we get a function g of x equals 2 to the power of sine x squared minus 4. What would be the derivative of that? Again, it does look a little bit, looks like a very scary derivative to evaluate, but if you really think about it, it's not that bad, because essentially what we're doing is we're just following this format here. So what we're going to do is g prime at x, okay, the derivative g prime at x is equal to a to the power of whatever the exponent is, so 2 to the power of sine x squared minus 4 times the derivative of, or sorry, ln a first, so ln 2, okay, in this case a is 2, times the derivative of this exponent. Now, the derivative of a sine function is cos, okay, so the derivative of sine x is cos x. So we can write times cos x squared minus 4, okay, and then of course we have to multiply that by the derivative of whatever is inside this box, okay, so times 2x times 2x. Now what we can do is we can go ahead and simplify this further, but I just want to point out one thing here. So we notice how we have a base 2 here, and then we have a 2 here as well. Another way of looking at this number is, or let me grab a different color here. You can write this number as 2 to the power of 1, okay, times x. Okay, so that when we go to simplify it, we can simply just add up these two exponents. So it'll be sine x squared minus 4 plus 1. Okay, so I'll write that down here. So we'll go 2 to the power of sine x squared minus 4 plus 1. And then we'll continue on times ln 2 cos x squared minus 4. And there you have it. So that would be the derivative of this particular function, and that is how you calculate the derivative of a general exponential function.